what for this one, they're both secant segments, but the top one, what are two values whenever you multiply? And keep going, Jeremiah. For the other secant segment, what two values am I going to be multiplying?
X minus 2 times 2x plus 2.
X minus 2 times 2x minus 2. Now, that is two binomials.
Plus 2 foils. Plus 2.
My bad. I had it. Anyways, thank you. We have two binomials that we're taking the product of. Please remember how to take the product of these two values correctly. This is just Algebra 1 skills. You're multiplying two binomials. One of my students yesterday said that, oh yeah, we got to double distribute. I've never heard that, but I like that a million times more than I do FOIL, that's for sure. Because that breaks down when you have a binomial times a trinomial, so I'd rather you say double distribute. But we are applying the distributive property twice. We first need to distribute x, positive x, to both terms in that second binomial, and then we need to do the same thing. We need to distribute the negative 2 to both terms. And that was a fun topic when they said double distribute, because then we started talking about the double rainbow guy. So you got out of here.
Double rainbow.
Yeah, don't worry about it. It wasn't worth the discussion. It's for sure. Take the products, and then before you move on, just check with your group mates that we all have the same product. Is everyone okay with that? Okay, fantastic. So now we've opened up a whole new can of worms. Okay, so I understand that this is a new theorem, a new topic dealing with these secant segments and so on and so forth, and we're trying to find the lengths of them. And then this is a blast from the past with the distributive property. And then now we have a lot of different terms going on. We have a term with a variable that's being squared. We have that same variable that's being raised to the first power, and then we got some constants. Constants are just normal plain Jane numbers, because -4 is -4. It's constantly that. It's a constant. However, variables, they vary. I don't know what that was. Man. Anyways, so that's why we call them variables, because the value can vary and apparently dance. So when that happens, when you have a variable that's being squared, you have that same variable raised to the first power, and you got constants. That should be the red flags and sirens in your head saying what?
Set one side to 0, you
Yeah.
get quadratic.
This is a quadratic equation. So the first step is to set the thing equal to 0. So how am I going to go ahead and do that?
Subtract 36.
36.
Subtract 36 from both sides. Good. All right. So I have got that 0 is equal to 2x squared minus 2x minus 40. Now, some of you may have done something different right here. Did anyone have any other thoughts of what to do before we subtracted 36 from both sides? What's up, Keegan?
Square rooted the 2x squared, and then square root the other side of 36.
If we took the square root of everything, then this would be the square root of 2x. This would be the square root of 2 square root of x. We would get a lot of square roots involved. We can't do that because there's those 3 terms there. Jeremiah, what did you say?
I say divide by 2.
Divide by 2. That's legit if you were to do that at first, because we need the term with the squared variable, we need its coefficient to be 1. So we need to take care of that right now. We need to do that. So now we're going to divide by 2. you would have divided by 2 first. You would have got 18 equals x squared minus x minus 2. Subtract 18 from both sides. You're going to get the same thing. Okay, so those 2 steps you could have did in a different order. But that's good that you recognized and noticed, I need to get this leading coefficient to 1. But that's fantastic and that's great. Whether that's before you set it equal to 0 or after. But you need to make sure those 2 things happen. That you set this thing equal to 0 and you make sure that your leading coefficient is a positive 1. Positive 1. Alright, so now we got this. We got this quadratic that we need to solve. Right now, we have the value of C is negative 20, and the value of B is negative 1. If your Algebra 1 teacher taught you how to use the quadratic equation, fantastic, then use it. That's that whole negative B plus or minus the square root of blah, 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 blah. If you know how to use that, great. Go ahead and do it, okay? If your teacher taught you to plug into the calculator and you know how to use the calculator correctly and find the values of x, fantastic. The way that we've been doing it all year long is we've been factoring this by hand and applying the 0 product rule. That's how we've been doing it the entire time, so I'm going to continue doing that. Okay? Cool. So I need to find 2 values whose product is a negative 20, but they sum up to be a negative 1. And these signs tell you a lot about these 2 values. The fact that this is a negative and the product is going to be a negative 20, what does that tell me about these 2 values? Different signs. Yeah, one's positive, one's negative. Okay? Then, the fact that their sum is negative, what else does that tell me?
The negative is a larger number.
Right. When you look at the absolute value of these two numbers, the negative one is going to have a larger absolute value. So I need to find 2 numbers whose product is negative 20, and the larger one needs to be the negative one. So I'm going to start with 1. 1 and negative 20. Their product is a negative 20. However, do they sum up to be a negative 1? No. Okay. 2 and negative 10. Their product is negative 20, but do they add up to be a negative 1? No. 4 and a negative 5. Their product is a negative 20. Do they add up to be a negative 1? Yes. Fantastic. There we are. So, 0 is equal to x plus 4 times x minus 5. I am not done. I have yet to say that x equals some value. I still have this, x plus 4 and x minus 5. I need x equals some number. So this is where we apply the 0 product rule. Right now we have the product of these 2 binomials, and apparently when we take the product, it equals 0. The only way that can happen when you multiply 2 values and the product is 0 is if one of these is 0. That's the only way you can get a product of 0, is if one of those values you're multiplying is 0. So, either x plus 4 has got to equal 0, because 0 times anything, it doesn't matter, will be 0. Or x minus 5 has got to be 0. Because again, 0 times anything is going to give me 0. One of these has got to happen. So now I can finally solve this equation and get x is. I'm going to subtract 4 on both sides, and I got x is negative 4. And over here, I'm going to add 5 to both sides, and I know that x is a positive 5. Now, you cannot let yourself get in the habit of just disregarding the negative value and be like, oh, we don't need the negative value, it doesn't work. And that showed on y'all's test, because there was a question on the test that a negative and a positive value both worked, and a lot of us just negated the negative value and didn't write it down. That's bad. Do not let yourself get into that habit, because all your next math classes, Algebra 2, pre-calculus, calculus, even if you go the route of AQR, math models, which none of you are going to do that, but you're going to encounter this negative value, and you are going to use it, and look at the implications of that being a negative number. Now with geometry, we have like more of a real-world application, because we're looking at lengths of segments. If we were to take that negative value and plug it in, negative 4 minus 2, well, that segment's length can't be negative 6. So yes, in this class, 8 times out of 10, we do kind of not disregard, but we don't write down as a final answer that x is negative because we're talking about lengths, and lengths can be negative. We're talking about measurements, and we don't want negative measurements and areas and so on and so forth. But please do not get in the habit of disregarding this. You need to be able to find all possible values of x. But we would accept x equals 5 as the only answer, because that's when we would get positive values. Okay, let's take a break.
What's mathematics?